Today we will know about the basic terms used in wave propagation, in which first we are taking amplitude and phase of a wave. In the above given figure, amplitude of wave, which is expressed by A, usually it is the maximum displacement, it is the magnitude of maximum displacement of the element from its equilibrium position as the wave passes through it. In the given figure, you can see that the maximum displacement of a particle is shown here, say at point A, at point B, at point C, and at point D. Here the A, B, C, D are the maximum displacement of different particles vibrating during the propagation of the wave. Now what is the phase of wave? That we express in terms of phi, phase of wave. It depicts the state of motion and changes linearly with time. As we know, we generally express the displacement equation for waveform yxt equals to a sine kx minus omega t plus phi. In the above equation, the argument kx minus omega t plus phi is the part of interest to us in this column, since we know that value of sine function, value of sine term has range from -1 to +1. The value of displacement of particle also velocity of particle at position x is -a for sine kx minus omega t plus phi equals to 1. Sine kx minus omega t plus phi equals to -1. Here phi is known as initial phase angle and its value is determined by initial displacement and velocity. Initial displacement and velocity of the element at x equals to 0 and t equals to 0. Now we will discuss what is the wavelength and angular wave number. Wavelength, expressed as lambda, it is the distance parallel to wave propagation and its direction between two consecutive separation of wave shape. Sorry, two consecutive repetitions of a wave shape. You can see the diagram here given below. In the given figure, wave shape is same at points P and R, or we can say amplitude of wave is maximum at both P and R points. So what does it mean? That the distance between P and R here is called wavelength measured along x-axis. Also we can define the wavelength in different manners, in which we can say for the wavelength that minimum distance between two consecutive troughs and crest. Troughs, two consecutive crests or troughs is known as wavelength. You can see in the diagram given above where the points P and R at the crest of the waveform, and both of the crests are consecutive. It means the distance between two consecutive crests will be called the wavelength. Similarly, we can define wavelength in another manner. Difference between two consecutive points in same phase is known as wavelength. Again, you can see the given diagram where the point P and point R in the same phase. Similarly, you can draw another point here, say a point B and a point C, which will also be in the same phase. So the distance along the x-axis between B and C will also be considered as a wavelength. Now, for the displacement equation of waveform, if yx0 equals to a sine kx equals to a sine kx. Then the displacement along the y-axis and at the two ends of a wavelength are same. So we can consider here that initially if the displacement at the first end of the wavelength is x equals to x1 and at the last end of a wavelength the displacement is x equals to x1 plus lambda, then a sin kx1 will be equals to a sin k in bracket x1 plus lambda. From the above relation number 2, we can say here that equation 2 will be satisfied if and only k lambda equals to 2 pi n, where n is the value 0, 1, 2, 3, 4, the all integers to the infinite. Since n equals to 0 is considered for reference point, or you can say point of starting for n equals to 1, we find that k lambda will be equals to 2 pi, or we can say k equals to 2 pi upon lambda. This relation is the relation between the wavelength and the number of wave, because here k is considered propagation constant or angular wave number, and its SI unit is given by radian per meter. So that's all for today, where we have studied the phase, the wavelength and the amplitude. We will continue in the next turn. Thank you all.